Hello, this is Ahmad Mirabi. In this video I want to teach about molecular geometry or the shapes of molecules and what factors affect the shapes of molecules. We need to know the Lewis structure before this, how to draw a Lewis structure of different molecules. Then I'll draw a table here and start by saying that number of electron regions affect the shapes of molecule, number of electron regions around the central atom in a molecular compound, and then the general shape, how the general shape will be, and what is the bond angle, roughly what is the bond angle. I'll explain it and we'll make some examples. If we have two electron regions, like the case we have in CO2, in CO2 we have two electron regions here, 1, 2. Though each electron region has 4 electrons inside it, but around carbon atom there are 2 electron regions. So because electrons repel each other, they stand in an angle farthest apart from each other. That's why this is 180 angle, and the shape of the molecule is linear. The angle is 180. Another example for 2 electron region is HCN. In the case of HCN, carbon atom has a triple bond with nitrogen and a 1 single bond with hydrogen. Again, we have 2 electron regions here, so they repel each other and the angle will be 180. It's a linear molecule. When we have 3 electron regions, like the case in SO3, of course in SO3 we have some hybridization here, that the bond order is greater than 1. We'll not talk about this for now, but around the sulfur atom there are 3 electron regions here, and they are just identical with each other. So because electrons repel each other, they will form a 120 degree from each other, and this is the farthest apart. This is the farthest distance these bonds can have from each other. So the angle is 120 and the shape is trigonal planar. Another example we can make for 3 electron region is a molecule like this. Here carbon has a double bond with oxygen and 1 single bond with hydrogen, another single bond with hydrogen. Again, we have 3 electron regions here. 3 electron regions make it a planar molecule, and the angles are roughly 120. It may be a bit less than or greater than 120, but this estimation of 120 is good enough. Okay, when we have 4 electron regions around the central atom, something like methane. The methane has 4 hydrogen connected to the central atom, so we'll have a tetrahedral shape like this. 1 hydrogen here, another hydrogen here, until here, all in the same plane. Then it's like edge which is coming out of the page, and a dash which is going into the page. I'll show it to show that CH4 is a 3-dimensional figure. The shape is a tetrahedral the shape is tetrahedral. The general shape is tetrahedral, and the angles are 109.5, because this is the farthest these bonds can be from each other, because the electrons want to repel each other based on the VSEPR, which is the valence shell electron pair repulsion. The electron pairs want to repel each other, so they'll form the angle of 109.5. If we want to make more examples can be made with 4 electron regions like NH3. In the case of NH3, we have 1 lone pair and 3 bonding pairs. So again, if we count it, 1 electron region, 2 electron region, 3 electron region, and 4 electron region. Here the lone pair is counted 1 electron region here. So again, we have 4 electron regions. So the angles are roughly 109, but because the lone pair is more free to move, so it exerts more repulsion to the bonding pairs. That's why the angles here will be 107 instead of 109.5. So, but generally the form of molecule is tetrahedral. Generally it's a generally that rule applies. And the case of water molecule, again the same applies, because in the water molecules we have 1 oxygen connected to 2 hydrogen. So this is 1 electron region, 2 and 3 and 4, and this angle will be 104.5, because again 2 lone pairs are free to move, are not bounded to 2 atoms. They're more free to move, and so they exert more repulsion force to the bonding to these bonds. That's why the angle will be smaller than in the case of methane. So all of these, the general form, we can say the general form is tetrahedral. It has 4 electron regions, and but the shape in molecule H2O molecule, we can say the molecule is bent, because not considering the lone pairs, just considering the atoms, it's a bent molecule like this. And in the case of ammonia here, NH3, it's a trigonal pyramidal. It's a pyramid, trigonal pyramid. Trigonal pyramid. We can continue the table by let me choose this tool and let me see if I can erase these like this. Okay, it worked. Now 5 electron region will have trigonal bipyramidal. Trigonal bipyramidal. Bipyramidal. The general shape is like this, and I'll tell you what the angles will be. For example, in the case of PCl5, one phosphorus is connected to 3 chlorine atoms. This will be in a plane, and then 1 covalent bond up the plane, perpendicular to the plane, and then one is down. So considering this shape, it's a pyramid, but the base is triangle. But since you have the upper pyramid and lower pyramid. It's a bipyramidal, trigonal bipyramidal. The angles will be 120 and 90, and of course 180 angle. Also we have the one which is up and down, the angle is 180, and these ones are 90, and then those in the planes will make 120 angle. And when we have 6 electron regions, like the case of SF6, the sulfurous, and 4 fluorines are inside a plane, making a square, one up and one down. So it is a octahedral. It will be a square pyramid up and a square pyramid down. And generally we can say it's a octahedral. Let me write here octahedral, because it has 8 surfaces. This general shape has 8 surfaces, so it is octahedral. The angles will be 90, and one of the angles is 180. Most of the angles is 90. Okay, this is a general rule for the molecular shapes and geometry of molecules. Of course, we can have some cases when we have 5 electron regions, one of them is lone pair, 4 of them are bonding pair, or we have 2 lone pairs. We have some variations in this, but it is enough for here. I don't want the video to be long. Okay, let me finish the video here.